and the speed are the same due to the 100-meter straight of the track. All his velocity scores are the same as his speed because there's been no change in angle, and this is sustained throughout. Moving on, then you have acceleration. As we learned before, the equation for acceleration is the final velocity minus the initial velocity divided by the time taken. Usain Bolt's acceleration during the first 20 meters of the race was perhaps his greatest during the race, as he's going from a starting initial velocity of 0, and the final velocity at the 20 meters of that section was 6.92. So 6.92 minus 0 obviously equals 6.992, and then you divide that by the time taken being 2.89, gives the acceleration of the initial 20 meters of 2.39 meters per second squared. Following on from that, you have his greatest acceleration during the race, of which was the 20 to 40 meter period, as the final velocity at 40 meters was 11.42. You minus that by the final velocity of the 20 meter point, so the initial velocity in this instance, so might take away 6.92. That gives us a score of 4.5. From then on, we'll divide that by the time it took him to complete that 20 meters, so 1.75. Divide them two together gives you 2.57 meters per second squared. Again, the middle part of the race, 11.97 seconds was his final velocity at 60 meters. You take that away from his velocity at 40 meters, which was 11.42, which gives you 0.55, and you divide that by the time taken again, 1.67, and that gives you 0.32 meters squared per second. So this shows he's at a much more sustained speed than before, and he's not accelerating as greatly. His acceleration then becomes less, but he is still at the 60 to 80 meter point, as the change of the final velocity to the initial velocity is at a shorter point. It's 12.42 minus 11.97, which gives 0.45, and then divide that again by the time taken, 1.61, and that gives a acceleration point of 0.27. And then for the last 20 meters of the race, you have when he begins to decelerate. As he's reached his maximum point, his final velocity is less than what his initial velocity is, the 80 meter point to the 100 meter point. So you take 12.04, and you take 12.42 away from that. That gives you 0.38, and divide that by 1.66, the time in which it took to complete the last 20 meters of the race, and that gives you a total of minus 2.04 meters per second. So at this next point, we can now see Bolt actually performing the 100 meter sprint in his world record time. So as we watch it, he'll actually up. So this initial point here, extending to 40 meters, is great acceleration. As he comes down the rest of the track, he's at a sustained speed, and then throughout the period of the race, he's decelerating as he knows that he is finishing that point in the race. Contrastingly, if we watch that over again, we can see Tyson Gay in the left of him. He again is performing the traits more towards the starting point of the race. Gradually, as he furthermore goes on during the race, he's achieving a more sustained speed, and then he begins to decelerate towards the end of the race, just like Bolt does in this instance. If we are now to analyse Tyson Gay's speed, velocity and acceleration from that race, we'll do the same equations that we have done before. So 20 meters for the initial 20 meters, 20 meters divided by 2.92 gives 6.84. 20 meters divided by 1.78 seconds gives us 11.23 meters per second. 20 meters divided by 1.69 seconds gives us 11.83 meters per second. Then on we get 20 meters divided by 1.63 seconds, which gives us a total of 12.26 meters per second. And then his final 20 meters of the race, 20 meters divided by 1.69, gives us a total of 11.83, which shows that he was still going at incredible speed, but just to a very much lesser extent. From then on, we can view his speed as a whole total of the race, as he ran 100 meters divided by 9.71 seconds, which gives us his overall time. This gives us his speed throughout the race being 10.29 meters per second. Again, his velocity is exactly the same just as Bolt's, as they both perform in a 100 meter sprint, which is in a straight line with no direction changes. His velocity will be the same as what his speed is. And then moving on, our acceleration will be 6.84 final velocity minus the naught of the initial velocity, and then that will give us 6.84. That will then be divided by 2.92, so is time taken, giving us a total of 2.3 meters per second squared. The next 20 meters is initial velocity of 6.84 taken away from a final velocity of 11.23, giving us 4.39 divided by 1.78 seconds, giving us 2.4 meters per second squared. This was his fastest acceleration during the race. Next of all, we have 11.38 seconds as his final velocity minus 11.23 of his initial velocity, giving us 0.6 divided by 1.69, giving us an acceleration of 0.35. The next 20 meter block is 12.26 of a final velocity. The initial velocity being 11.83, taking that away from the final velocity, giving us 0.43 divided by 1.63 seconds, giving us 0.26 meters per second, showing us that he is accelerating to a lesser extent, but is still. And then the final 20 meters, we can clearly see that his acceleration is starting to become deceleration, as the 11.83 of his final velocity is less than that of his initial velocity of 12.26, so that gives us a total of minus 0.43, and the time that took him to complete was 1.69 seconds, so he's now decelerating at a rate of minus 2.12 meters per second squared. And then finally, if we were to compare Usain Bolt and Tyson Gay's data from that race, we'll clearly see that Bolt's speed and velocity is greater throughout the race. Each split time of a 20 meter section is greater in favour of Bolt. He's quicker at every section, even though he was only 0.13 seconds faster than him in the race. He was greater at every statistic. And then on the other hand, we can see that Tyson Gay decelerates at a much quicker rate, showing that he is either starting to fatigue at a lot quicker rate than what Bolt is, or Bolt is decelerating at a much slower rate, which shows that he has been able to sustain a greater acceleration and a greater maximal speed for a longer period of time.